Welcome. In this video, we will be finding the probability of a normally distributed variable using a cumulative standard normal distribution table. So here are the steps to find the probability of a normally distributed variable. So the first step is we will draw a normal curve and shade the desired area. So there may be three cases. One would be we would like to determine the probability of area to the left of z, or to the right, or in between. So by the way, here are the corresponding formulas for converting your variables into corresponding z scores. This is the formula for population, and this is the formula for converting your z scores from sample. So step 2, we find the z value corresponding to a given number x1 or x2. And third step would be to find the probability or the area in the table. So we need to have a cumulative standard normal distribution table. So again, these are the three cases. So case 1 would be maybe we wanted to find the probability to the left of any z value. So in this case, if we are interested in this area here, then our p sub z to the left would be this. Now, this is for case number 1. Case 2 would be if we wanted to find to the right of any z value. So in this case, this is our area of interest. So from the table, we simply find p sub z, then we have 1 minus p sub z would give us this area here. So that is how we find the probability to the right of any z value. Then the third case would be between any two z values. So if this is our z sub 2 and this is z sub 1, then to find the area in between, we simply need to determine p sub z sub 2 minus p sub z1, which will give you this corresponding area here. Okay? So let us have an illustrative example. An adult has on average 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. So we take note that the average is 5.2. Then we have the standard deviation of 0.3. And we wanted to find the percentage of people who have less than 5.4 liters of blood. So we draw the first step would be we draw the normal curve. So in this case, we draw the normal curve and the average is 5.2, and we wanted to determine the percentage of people with less than 5.4 liters of blood. So this is our area of interest as shown here. Okay, now step 2 would be we will convert this into an equivalent z-score. So our z-score from the formula, so it is computed that our z-score is 0.67. So we now have this corresponding z-score, or we wanted to find the probability for z equals to 0.67. So this is case 1. Our next step would be, we will find the probability using the table. So from the table, take note that we wanted to find the probability of p sub z is equals to 0.67 to the left. So from the table, we have 0.67, the intersection is 0.7486. So therefore, we have 74.86% of adults have less than 5.4 liters of blood in their system. So that is how we determine the probability for z is equals to 0.67 to the left. So again, here is our answer. So we will have next illustrative example. Example number 2. Each month, a Bisliganon household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the variable is approximately normally distributed and the standard deviation is 2 pounds. If a household is selected at random, find the probability of its generating A, between 27 and 31 pounds per month, and B, more than 30.2 pounds per month. So let us first solve for A, between 27 and 31 pounds per month. Now again, the first step would be to draw a normal curve, and take note that our average is 28 pounds. So we have this corresponding average. And our, we have 27, between 27 and 31. So we drew that out in our normal curve, and this is our area of interest. So between 2z values. Now, our next step would be, step number 2, we convert that into an equivalent z-scores. So from the computations, since our for x equals to 27 and we have the mean is 28 and standard deviation is 2, so we have z1 is 0.5, negative 0.5, and for z2, computing in the same manner, we have z sub 2 is equals to 1.5, and we draw that into our normal curve. So we are interested in finding the area between z equal to 1.5 and z equal to negative 0.5. So to find the appropriate area, we will be using the table. So again, take note, we wanted to determine p sub z is 1.5 and p sub z is equals to negative 0.5. Using the table, we have 1.5 corresponding to 1.5. P is 0.9332, and for p sub z is equals to negative 0.5. From the intersection, we have 0.3085. So the area between z sub 2 and z sub 1 is 0.9332 minus 0.3085, which is equal to 0.6247. So this area here is equals to 0.6247. So that is the probability. So next, for letter B, more than 30.2 pounds per month. So again, we draw, step number 1 for letter B, we draw a normal curve. So again, our average is 28 and we wanted to determine more than of the probability for more than 30.2. So this is our area of interest. So we convert this into equivalent z-score. So computing for our z-score, it corresponds to 1.1. Okay? So from the table, using the table, the standard cumulative normal distribution table, we have 1.1 corresponds to probability of 0.8643. Now take note that the 0.8643 is to the left of z, which is 1.1. So, and we are interested in this area, so we simply subtract this probability to 1. So we have 1 minus 0.8643 is equal to 0.1357. So that is why we have this corresponding answer. Okay, so we have covered 3 illustrations of determining the probabilities for normally distributed variables. So we have 1 to the left of z, 2 to the right of z, and 3 between 2 z values. If you like the content of this video, click like and subscribe, and please share. Thank you.